The next presentation will be by Virág Kutnyánszky. It's an online presentation, right? Elke? It's recorded, so please take the screen.
Welcome everyone, my name is Virág Kutnyánszky and today I'd like to speak about the Hungarian ecological network in relation of birds in the area of the M6 motorways southern section in Hungary. As an introduction, first I'd like to talk about the state of bird population in Europe. As most of you probably heard, birds are disappearing in all of Europe. This tendency affects outstandingly the farmland birds the most. Researches show that the farmland bird population has decreased by 55% in the last 30 years. Unfortunately, regarding this problem, Hungary is not an exception. According to the data of BirdLife Hungary, the biodiversity of agricultural lands has decreased by 60% in the last 20 years. And some species, like the northern lapwing, has lost 60% of its population. So we should ask the question, why are our birds disappearing? According to literature, birds in Hungary can be grouped into 4 categories according to their ecological needs. We can identify farmland birds, forest birds, water birds, and birds of prey. Although these groups have different needs, some common patterns can be found in their preferences. They all prefer diversity, both in habitat patterns and in plant species covering the land. They thrive on extensively managed land and prefer edges where 2 land use categories meet. Some species, especially water birds and birds of prey, are sensitive to disturbance and human presence. Looking at the birds' ecological needs, we can already see what the problem is, right? The biggest question is what we can do about it. The aim of our research was to use the ecological network development as a tool for bird protection. We reviewed the national ecological network, identified the conflicts and potential areas to determine the functional extent of the network. We also examined the effect of the M6 and M9 motorways in the research area, and we are suggesting an ecological development. We took these results into account. Now a bit about the ecological network in Hungary. The National Ecological Network, otherwise the NECNET, is spatially defined in the Hungarian Regional Development Plan. It's divided into 3 categories: core areas, ecological corridors and buffer zones. The extent of the network was determined by national parks based on the occurrence data of protected species, and it hasn't changed much since it was first established in the year 2000. Our research area took place in southern Hungary on the right side of the Danube. We examined 2 landscapes, the Tolna County and the hills of Szekszárd, which you can see on the map. The hills of Szekszárd consist mostly out of forests and vineyards, while the Tolna County is a flat area, the floodplain of the Danube, and it's mostly agricultural land. Next to the Danube lies the biggest flat forest in Hungary, the protected area of Evince. There are 2 main motorways in the area, the M6, which connects Budapest to the southern center of Hungary, Pécs, and the M9, which is supposed to be a part of the southern Hungarian motorway ring, but as far as I know, has a new trail planned more south, so it will be forever be unfinished. Thanks to the diverse land use, more than 150 bird species were identified in the research area. The most iconic of them is the corn crake, the black stork, the white-tailed eagle, the black and red kite, and the short-eared owl. The ecological network covers about a third of the area. Mainly 80% is core areas, almost 20% are ecological corridors, and the buffer zones are basically non-existent. To review the NECNET, we chose 4 indicator species, 1 from each ecological groups. We took the occurrence data of the species, the relevance, the ecological needs and other aspects such as migration, protection and lifestyle into account. Then, using GIS methods, we assigned an ecological network to each indicator species. Then, when determining the final output, we also took natural indicators based on the natural aspects of the research area and conflict areas into account. We chose 4 indicator species, the red-backed shrike, the black stork, the little egret, the white and the white-tailed eagle. 2 of them, the stork and the eagle, are iconic species of the gametes. For the GIS modeling, we used the linkage mapper toolkit in ArcMap. for which we needed three input layers: the core areas, the Euclidean distances, and the resistance rasters for each species. The linkage pathways tool using using the least cost path method identified the least cost paths and corridors from which we truncated the species ecological networks. Then we use these results in conjunction with our other landscape-based indicators to determine the functional landscape-level ecological network of the area. For the resistance rasters, we used the land cover of the area, which was based on the current land cover data, the open source OpenStreetMap data completed with the local databases. To each land use category was assigned a resistance value from 1 to 100. You can observe on the map that the black stork's resistance raster is far more contrasting than the eagles or the shrikes, showing its specific preferences. The core areas were the areas with a resistance value of 1, and from these patches we eliminated the ones that didn't have the suitable patch size for the indicator species. Then we calculated with the Conifer plugin of ArcMap the Euclidean distances between the cores. The least cost paths and corridors show very different pictures for each indicator species, as expected. You can see the preferred links and are more narrow for the black stork, while almost the whole area is suitable for some extent for the shrike and the eagle. You can also see the influence of the streams and channels on the egrets map. Truncating these corridors, we can determine the bird-specific ecological networks. Afterwards, we calculated a buffer zone around all water surfaces, which is the area we suggest should be the part of the ecological network. For streams and channels, this zone was 50 meters. For rivers and lakes, it was 100 meters. We also specified the areas disposed to erosion. For this indicator, we used the model data and did a slope analysis on the layer. Erosion is present on the areas over a 12% slope, and to avoid fragmented small patches, we eliminated polygons under 10 hectares. The result can be seen on the map. When determining conflict areas, we mean elements that can be harmful for birds. So near these elements, the ecological network development is not suggested. We examined motorways, airports, high voltage cables, railways, and wind turbines in the area. Summarizing these indicators, we can see the areas that are the most important from an ecological point of view. The more green an area is, the more indicators suggest that the area should be part of the ecological network. The map also shows the way our two motorways cause a conflict. Regarding the M6 motorway, it lies between Gemence and the forests of Szekszárd, both large, valuable protected areas. It also separates the Lake Kapszeg from the Oxbow of Tolna, causing these links a dysfunction. And you can observe how close the motorway lies to the lake. When you drive, you can see the mass of reed from your window of the car. The M6 motorway also causes conflict. It separates the Oxbow of Tolna from Gemence. Comparing these results to the NECANET, we can observe a few things. Firstly, we can identify some key areas that have a high ecological value but not part of the NECANET. Such areas are vineyards of Szekszárd and the areas around Virág, which consists of villages, gardens, orchards, vineyards, forests, and small patches of farmland. On the second look, we can also spot a green halo around all NECANET cores. This shows the absence of buffer zones in the research area. If we want to simplify our network, we could say that there are some links between our core areas, but a lot of them are missing, and furthermore, some are even separated with a motorway in between. To achieve a functioning landscape-level ecological network, these links have to be reinstalled and buffer zones should be designated. To summarize, the conclusions we could state are that the NECANET is missing some key areas on the landscape level, but these areas are not habitats with high natural value, but semi-natural, man-influenced, exploited areas, vineyards, meadows, gardens, small patches of farmland, and forests in between. The motorways in the research area cause some highly serious conflicts that can only be solved or decreased with the development of the ecological network. Thank you for your attention.
Thank you, Virág. You are online, I believe. Are there questions?
Yes.
Then maybe I can ask about the implementation of your results. Does the Hungarian road administration work with it? What are the plans for addressing these fragmentation problems?
Actually, not. We didn't communicate with them. I communicated with regional planners mostly, who are responsible for determining where the roads will actually be built. Mm-hmm. But they not implement my results.
But you intend to approach them and involve them in solution finding?
The regional planners or the road management?
Yeah, both.
My studies are mostly about ecological networks and not about the traffic system. So yeah. The road management not, but the regional planners, yes.
Okay, good. Thank you very much. Oh, there is a question. Daryl, please.
Very good. Thank you very much for that talk. If you were able to nominate one specific thing that would address the problem, what would it be?
That's a good question. I didn't think about that yet. I think the buffer zones is the most important problem of this study, and I would suggest that the buffer zones should change the land use. So in the buffer zones, the land use should be changed, and that's what I would implement the most.
Okay, and do you think that's in any way likely to happen?
Because of the weather this year, there was a big drought, and you know, as we have the climate change as well, I think in the future it can happen.
Okay, wonderful.
Okay, thank you very much.